This question concerns the volume of a triangular prism and the volume of a sphere. I'll give you a few seconds to read it carefully before I continue. So the first part of the question really is to determine what is the volume of gold that exists in the ingot. Well, the volume of a triangular prism is simply the area of its triangular face multiplied by the length that it's extended over. So the first thing we've got to do is calculate the area of the triangular face. We are told that the triangle is in the form of an equilateral triangle, each of sides being 6 centimeters. Because it is equilateral, we know that it is also isosceles, which means that the perpendicular from the vertex meets the base halfway, which means that this is a right angle and this is 3 centimeters. So we can use Pythagoras to work out what the height is. Pythagoras tells us that the hypotenuse squared is equal to side squared plus the side squared. Well, we don't know the height. We do know the 6, the hypotenuse, and we do know the 3. So 6 squared is equal to 3 squared plus the height squared. So 36 equals 9 plus the height squared. So the height squared must equal 36 minus 9, which is 27. And so the height is the square root of 27. And we can do that on the calculator quickly. And the square root of 27 is 5.196. So now we know the height, I can work out what the entire area is. The area of a triangle is half times the base times the height, which is a half times 6 times 5.196, which is 15.588 centimeters squared. Now that we know that the cross section here is 15.588, all we need to do to find the volume of the prism is multiply that cross section by the length that it's extended over, and we're told that that length is 14. So the volume is 15.588 multiplied by 14, which is 218.24 cubic centimeters. Okay, now we know the volume of gold that's going to be melted down. If it's going to become a sphere of diameter 3 centimeters, and we know that the volume of a sphere is 4/3 pi r cubed, where r is the radius, then we need to use the fact that the radius is going to be 1.5. So what is the volume of a sphere of radius 1.5? And it's 4/3 times pi times 1.5 cubed. And that is 14.14 centimeters cubed. So if we've got 218 centimeters cubed of gold, and each sphere takes up 14 centimeters cubed of gold, how many spheres can we get? So we need to divide the volume of the gold ingot, 218.24, by the fact that one sphere is 14.14, and clearly we should have something in the order of 15 of these, and indeed the answer is indeed 15.43. So I suppose the technical answer is we can get 15 spheres out of this gold ingot.